What is going on, YouTube? I'm back. I'm just gonna check if the sound's good, because right now it looks like it's too loud. But let me just make sure the stream's good before I start talking. See, I got the live stream on my phone. I got the live stream on my phone. Alright, perfect. Alright, sound looks good. Let's get started. I'm CADing today. I was developing in my previous streams, but I decided that I want to. Well, I should backtrack because I started going to a hackerspace in New Jersey, and I brought motors, which I'll show you. Hold on one sec. They're big. Hold on. So you see that yellow container under the Aeroboticar in the background? That contains these motors and the components for a flying car. This is by T-Motor. Just to give you some context, these are the size of the motors, so they're pretty big and they're heavy. Okay, so you power them here with a 3-phase PWM controller, which is what the ESCs are, through a flight controller, which is this right here, this flight controller. But this is a small scale. Okay, this is small scale. We're building it small first to make sure that what I'm trying to do works on a small scale before we scale up. But in the future, we will be building this in a human flight capacity. So let me just put this away. Okay, so that's kind of the backstory. I've been going to a hackerspace. I told them, hey, like, can I build the large scale here? And they were like, yeah, absolutely, it's gonna cost like $110 a month to keep the lights on, which is better than paying for like $300,000 facility on my own. I could just share it, and it's like a business there, so they make money and they're able to pay for the building. This is kind of the stuff I think about. I know it's probably not interesting to you, but I was like, can I build it here? And they were like, it's up to you if you want to start right away, or if you want to build like a small scale version to demonstrate that it works to investors, so that we can get like grants from the state to sort of fund the project. Like I have $20,000 worth of components, but we still need the frame, the batteries, and the frame and batteries alone are probably in the range of $10,000, I would say, maybe a little bit more. depending on how we make these parts right here, this for example, if you run this through a milling process like a PCB way, they'd probably charge you like $300 or more just to make this part. And I have a lot of those parts. As you can see, this frame is made up mostly of those parts. So if we get the materials on our own and like buy a CNC machine that the state funds through the grant, I don't know how much CNC machines cost actually. I should probably look into that. How much does an aluminum CNC machine cost? This is probably something I should know. Isn't it great? Like, AI can just... This cost of a CNC machine varies dramatically, ranging from a few hundred hobbyist desktop model to $500,000 for high production industrial machine. The price depends on the machine's size, rigidity, precision, and features. Here's a general breakdown of what you can expect at different price points. Okay. I would say between like a desktop CNC and entry-level industrial. 4x8 foot CNC routers with enough power and rigidity to handle aluminum sheet production. Prosumer or desktop mill range. So what if I wanted to make this part? Let's see what it says. What if I wanted to make this part? It's probably around... It's probably less than a cubic foot. Yeah, because PCB way is expensive, you know, they charge you a lot. I could potentially get sponsored by them. That's a great looking part and a perfect example of a 3-axis CNC milling job because it features on multiple sides. With holes in a central curve profile, it's more complex than a simple flat part. If you buy a machine to make it, this part is too complex for entry-level hobbyist machines. You would need a machine with significant rigidity and the ability to handle multi-step operations where you clamp the part machine one side, then flip it over and machine the other. High-end hobbyist prosumer machines like Shapioco 5 with upgrades or Onefinity could technically make this part with a lot of careful setup and patience. Desktop CNC. This is the category built for parts exactly like this. A Tormac like the PCN 440 or 770M is the classic example. These are designed for the rigidity and precision needed to cut 3D aluminum parts like your coupler. If you pay a service to make it. For a single one-off part, you should expect a cost of $300 to $900. So if I have like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So if I have 21 plus parts, let's say 24, because I didn't count accurately, times 900, 21K. So it would pay off to get a CNC mill machine. And then blocks of aluminum. Tormac. $5,000 to $15,000. PCNC 440. Yeah, so like something like this. You could probably get like a CNC machine for aluminum. And how much are blocks of aluminum? Blocks of aluminum on Amazon. Yeah. So depending on how big you need them, 8 inches looks like kind of the standard. How would you like cut it? I wonder how you cut these. But yeah, you buy aluminum and it's not expensive at all. It looks like these are not expensive at all. From literally Amazon, so the supply chain is good for aluminum. Alright, so that's kind of the plan for the full scale. And then these tubes as well. I have an example, it's behind the couch. But these tubes are pretty expensive. I think in total, I'm not really too like in the direction of trying to build the full scale. Like this will scale up, so I am technically, but all of my numbers right now in my head are for the small scale. So this is gonna look, I'm gonna show you a person to scale. So this mannequin, this is how big it's gonna be. So essentially like this thing right here, it's gonna be about that big, but it's actually gonna fly this time. So yeah, let's kind of work on it, because there's a few things that I need to do. Like for example, I figured out that I need 2 batteries because there's 8 motors, and each motor has a peak current of 55 amps. So 55 amps times 8, 55 times 8, 440 amps. So one battery can't contribute all of that necessary power. There would be a voltage lag, and Aeroboticar's small scale prototype will fall out of the sky if I use one battery. So divide that by 2 batteries running it as 2 separate systems, so it's a redundant power system. So this battery right here will be powering these 4, this motor, this motor, this motor, and this motor on this side. And then this battery, actually now that I come to think of it, now that I think about it, it can't be like that. It has to be, this battery powers the bottom ones, and this battery powers the top ones. This way, if one battery fails, the drone won't fall out of the sky. It will still have 4 of its motors. working, and it will kind of just it will still sort of I would have to configure the Pixhawk to make it so that, you know, I think they probably already have something like that, where all I would have to do is kind of just enable it in the settings, turn something from false to true, so that 4 motors can still work on if one battery system fails. So that's kind of the challenge right now, is setting these up. These are electronic speed controllers. They're kind of like the muscle that take the power from the battery and then take information from the brain to control it, and then they supply power to the motors. So those 3 little wires that you have on the motor that you just saw, they connect to this ESC, and yeah, they drive them. So the problem right now is space, because as you can see, I can't really go out any further with this tray, this battery tray, without it making it look stupid, and I do want to make it aesthetically pleasing for investors. So what I'm gonna have to do is actually, I could probably move this in a tiny bit in further. Okay. From the battery, distance, how far should it be? Oh, I'm like lagging. I wonder if it's because I'm streaming. I wonder if it's because I'm streaming. Yeah, it's because I'm streaming. I'm like lagging a little bit. I think that's inches. I could probably keep it tight because I'm gonna need bus bars here. So keep it tight, keep it right. And then from the center, I want to make sure that they don't overheat or anything. You know, they need some breathing room. Keep it tight, keep it right. Oh, there you go, it's not lagging anymore. Nice. I was like, really? My computer can't handle that? That's kind of weird. Keep it tight, keep it right. Oh, now I'm lagging. Did my CREO crash? Oh, okay, no, okay. Here, let me make this bigger. There you go. Now you can see. So this is the flying car, huh? Yep, this is it. This is the flying car right here. I've been working on this for 7 years to finally get something to fly, with the goal of making a full-scale prototype. And this scales up to human scale. So this is something that I'm very, 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 very proud of. Normal. No, not normal. Sorry. Come back. Distance. Keep it right. Keep it tight. Keep it right. Keep it tight. Alright. 0.4. Okay. And this gets... So right now I'm just constraining. I don't think it's registering that I'm trying to constrain it on the ground here. There you go. Okay, there you go. Now it's fully constrained. 0.4. For some reason it's not it's like not maybe I shouldn't constrain it onto the with respect to with respect to the other ESC. I should do it with respect to the same thing I did with the first one. Okay, so now there's just one vector left, and I think I did it with respect to the battery. I think I did like 0.5 inches from the battery. But it's not it's not constraining it. The blue line should go away, the blue vector. But it's not. And this whole thing should turn orange. Maybe if I do it with respect to that. No. Alright, well, that'll have to do. It's not working. But that kind of demonstrates how it's going to look. And then wires will be coming out of here and everything like that. So, and the battery will also have a wires and stuff coming out of it. So there's going to be 8 ESCs total. This is just the engineering process. It's very meticulous, sort of. There's no really calculations that I've had to. You haven't seen me model anything so far. I'm just kind of assembling things, but see how it's orange? Oops. Keep it right, keep it tight. So that's perfect, actually. That's actually really good news, because now I can create a sort of platform for the ESCs with some breathing room. They might get hot in here, not gonna lie. So a lot of electrical noise going on in here, but these are D-shot ESCs. I'll show you the ESCs. I don't think I've shown you those yet. T-Motor Alpha 60 amp ESC. These ones right here. 6S. Right here. So this is going to be like a $500 expense because I need 8 of them. So $559. that I'm going to spend on ESCs. But these are it. And this is how I got the dimensions. They literally give them to you. But I wonder if they have lightweight design on the promise of waterproof, dust resistant, and cooling performance. Lighter than square wave ESC of the same size. Alpha ESC is 15%. Okay, cooling performance. So these are probably going to be okay because they're very efficient, low temperature. So I don't think I really have to worry too much about them overheating or anything like that. So yeah. So 3D CAD is kind of like creating the Lego manual. If you've ever played with Legos. See, sometimes it constrains and then other times it doesn't, which I don't know why it doesn't do that. There you go. Distance 0.4. Perfect. The bus bars will have to fit right here. I have to create a bus bar. But yeah, I got super lucky with the dimensions that I wanted. Like, I literally want these dimensions, and the ESCs just so happen to fit. And then I need bus bars as well. So this little hole right here. So for a bus bar, it looks like this, right? This is a bus bar. So you could plug power onto this, and it's like a rail for your electronic speed controller. This is the positive one. There's also a black one that I was gonna put on the back. That's the negative terminal. And this took up a lot of space. So instead of having like 4 individual poles, I'm going to create one pole. So from this, I could really just create like, well, I could create like how would you say, how much space do I have? Let's measure how much space I have. So from here to here, analysis 4.3 inches. So I can make one about, it's gonna be tight, but I could probably do like 1.666666 inches. 1.6666 inches to millimeter. 42. Actually, 42 is the meaning of life. If you guys didn't know, if you've ever seen Hitchhiker's Guide to the Galaxy, 42 is the meaning of life. So let's do 42. 42 divided by 2. And then sort of we can get rid of these right here. Actually, yeah, we can. Okay, delete that. We can delete this. So now we're just left with this little thing. So we're gonna need to put an M8 bolt through it. So I like to start off very crude and rudimentary. So for example, what is what is the size of an M8 screw? That's what I need to know. M8 bolt size chart. The diameter of an M8 diameter is 8 millimeters, and a standard or coarse thread pitch metric in 8 inches. 8 indicates the nominal diameter. Okay, so it's 8. That's why it's 8. M8, 8 millimeters. So we're going to need about 8.2 just to make it fit. And good news, that's really good news, because as you can see, we have plenty of space for screws, mounting screws, and all that. Just make sure that that's the bottom. So just gonna make a bolt sort of head compartment for it. 20 is probably plenty, but I'm gonna be safe and do 24. And then you kind of just extrude it, remove material, and that's sort of the like compartment for it. 10 is probably plenty of room. And then I'm just going to move this up a little bit, maybe 20. Okay. So the bolt will go in here. Let's model a bolt. M8 bolt. Illegal characters. Inches part solid ABS. So this bolt will be I don't actually know what size bolt, like how big the head is. Let's call it that big. So this is gonna be 8. Let's do 8.1 just for tolerance purposes. And this is the fun part, because we need to figure out how much space we have under there. I'm guessing we probably have around 40. Save it, and then we can make it copper. Copper right here. So it's gonna look copper. And then we can create a new file called assembly, bus bar, red, inches ASM design, inches ASM design ABS. Okay, and then we could add our bus bar red, and then we have to constrain it, turn it orange basically. We only have to do this pretty much one time at the beginning. Okay, and then we're going to put a copper bolt, copper. What did I name it? M8 bolt. M8 bolt. Spin this around. Constrain the axes. And so this bolt will now act as a conductor for my bus bar. So this is kind of the, I probably have a lot more room than that. But then all of the terminals will sort of attach to this. So let's go back to our Aeroboticar. And now let's add the, what did I call it? Bus bar red assembly. And then put it over here. Okay. Oh, okay. I think 40 might be the limit. 40 might be actually the limit. We could delete this. That's just the base of the bus bar. So as you can see, we could probably take this and make this like 14. And I'm just making sure that so I want to give it space, right? I want to make sure that the distance from the copper head bolt, the head of the bolt, and the bottom of the container, I shouldn't have named it container, but so that it's not touching the ground. Okay. And we can paint this red. Okay. This is going to be 3D printed in ABSR plastic. So now we can take this and create sort of holes for the I'm going to say M2. M2 screws can hold this for sure. And I think I'm going to make this square, because right now it's 42 by 33. You know what? We could probably get away with 33. 33 divided by 2. 33.333. 33.333 divided by 2. Okay. So it makes it more compact. And then we're going to need screw holes on this. So let's see here. How can we do this? Just outlining the circle. We could probably put a hole right there. So this hole is gonna have to be about 4. Actually, no. An M2 screw is 2.2. Okay. So this is going to be mounted onto the battery tray. So we can do that. Put a hole through it. And then mirror this. And then mirror these two over that. So now we have 4 holes. And this is going to be mounted from the top. I believe it's going to be mounted from the top. So we're going to need another, like you know how a bolt has a head on it? A bolt has a head on it, so it's going to need to be, I'd say about 6 or 6.7, 6.5. So that should 6, 7. That should be enough. Sorry, I didn't mean to do that. That was just instinct. Okay. So the screws will kind of go in there. 5.7 is okay. Paint it red. Okay. So now you have your bus bar. And we can get rid of these sharp edges. Like that. And the 3D printer will take care of the rest. There's your bus bar mount. Bus bar red. Okay. And then let's make sure that it fits. See, we made it a little bit smaller. Okay. We could probably get away with just screwing in 2. You know, I made 4, but I'm thinking now we could probably get away with, I think 4 might be too. Yeah, I think we could do 2. Because then I'm going to be sitting there like screwing all of it in, you know. Actually, we can't do 2. We can do like a diagonal situation. I'll just leave it as is, and then when it comes to actually assembling it, I will only use 2 holes. This way, when it 3D prints, it will actually use less material, and it will look neater. Okay, so we got our bus bar. Actually, we should probably put this on the other side, over here. That's where our ESCs are. That's cutting it a little bit too close for my liking. Yeah, that's a little bit too close. However, I could probably get away with I could probably get away with 2.5 here. Actually, no, not 2.5. 2.63. I'm just trying to make it so that 2.69. The batteries will essentially have to be touching each other. Pause. 2.69. No, that can't work. 3. 2.8. And let's try to do 2.8 here. Okay, so there's barely any room for the batteries to move around. They are going to be strapped in. Now, that doesn't really give me any room to play with here. I guess I could do a little bit. Actually, what's the... distance. I could probably decrease the distance a little bit. Maybe like 0.2. And then I would have to oh, this one came first. Point two. Okay. I don't think that's a good either though, because I don't think that's good either because there's wires coming out of here, you know? So they're going to be smushed up against this battery. So we kind of have to undo that and give it some room for wires to come out of 0.5 is fine. Why are these so far back? Distance 0.5. Okay. The thing is, I think I'm gonna have to put this. Like on the edge here. I think if I put it on the edge, it should be okay. Oh, wait. If I put it like right on the edge, like that, the wires should be able to breathe here a little bit. And these are power wires, so there's only 2 power wires coming out from here. And they should be able to sort of come out and breathe. Okay. So now we need to make holes for this thing. So from here to here is how much? 0.18361. You know what? I could probably copy and paste. If I take this and take this guy, put center line, put whatever those are, go like that. C, copy, go onto the battery tray and paste it right here. Ratio is 1. The thing is, I don't know. I don't think that'll work actually. But you guys get what I'm trying to do, right? If I take from here to the edge, you know what, if I do this, create these lines. I wonder if that will work. Paste. And now this gap right here, I wonder if I can I wonder what will happen. Oh, that actually worked. Let's go. Nice. So that will be sort of the holes for the screws. And then I'm gonna need to copy these holes. I believe that's the center line. I don't think that is though. Huh. I think I did this wrong. Hold on. Cancel. I think it's like that. Oh, so those are the center lines. Okay, so take this, mirror it over this. Take that, mirror it over that, and then take that and mirror it over that. And I believe that should be okay. Those will be the mounts for the oh, and we need like screw hole like little things for it. So like that and like that. Like that and like that. This should be like, wait, why is this 2.3? It should be like 3 or maybe even 4, honestly. Let's do 3. And then remove material. These holes are too small though. You know what it is? I don't think I ratioed it when I pasted it. Yeah, I didn't ratio it. That's why they're so small. Okay, hold on. I forgot to ratio it. Remember when I did this whole thing? I forgot to make it 1:1 scale. So let's go over where that is right now. So it's right here. Oh wait. See this? I didn't do that. From here to here should be 0, and from here to here should be 0. Okay, and then this and this are this from here to here and from there to there. Okay, so now we just have to mirror this again. And then mirror that over this and mirror that over this. Mirror. Okay. And then go like that. And there you go, there's your holes. So now here, yep, it's perfectly aligned. So now I can take this guy, bus bar red, and take the axis of this and put it on the axis of that, and it will constrain. Okay, so there's your mounting holes. We just have to create the little you know what I'm talking about, the little, so that the screw's not sticking out, like a little compartment for the probably like 5 is good. It's gonna be tight, but two. Get it right, get it tight. All right. Now we can take this guy, and this guy, and mirror it over him. And now we have the same pattern over there, and then we can take this guy and mirror it over this guy. So now I can take bus bar red assembly, take the axis of this little hole right here, constrain it onto the axis of this little thing. Coincident. Okay, and then constrain it like that. So now I have bus bars on either side, and I need black bus bars as well. So I'm gonna take this, save a copy, bus bar black mount, I guess you can say. Open bus bar black mount, color it black. Okay, and then we're going to need, what is that called? Bus bar red. A new assembly called bus bar black. You can also call it negative, but I do not feel like doing that. Assembly design ABS. Assembly design ABS right here. save it. Bus bar black. This guy, bus bar black mount. Constrain it. Get it right, get it tight. Get it right, get it tight. Okay, and then we're gonna need our bolt, M8 bolt. I remember the name of this guy, which is upside down right now, so we have to spin it and then put this guy here on this axis. Coincident. And then coincident that again. Okay. And then we're gonna need to put, actually I'm gonna need the axis, and then we're gonna need to put bus bar black, put this axis right here, coincident, and do this right here. Okay, so now we have two terminals. Should negative be on the left or right with respect to the person looking at it? I mean, they're clearly labeled, right? You know what you could also do is get like a I guess we'll worry about that later, but I'm gonna need to make a cover. I'm gonna need to make a, can you guys even see? Let me see. Yeah. I'm gonna need to make a cover for these so they're not just like sticking out. But we can also make these bigger, I think. I'm not going to though, because just in case I need to put something here. So that should be fine for all the 4 motors, which I'm gonna have to wire like a power cable through here. Okay, so that's what it looks like so far with the bus bars. And I also, I'm gonna do like a shelf. I don't know how I'm gonna do that though, if that's gonna be a separate part that I'm gonna mount on, but I could probably I'm thinking. Oh, you know what I'm gonna need to do? I'm gonna need to create clamps for these ESCs. So this guy does not have mounting holes that I can screw and hold on, so I'm gonna need to clamp it. So I'm gonna need to create like a clamp for that. I'm just thinking how I would do that. And then that clamp could be the shelf for the top one, which will also be a clamp. That's a good idea. So I do have some clearance from here to here. Analysis, measure. I have 0.39278 inches on that side. And I have 0.4 inches that side. what was the number? 0.39. So I'm gonna need to work with 0.38. 0.38. So I'm gonna need to make a clamp shelf. Clamp shelf. Clamp shelf ESC part. Clamp shelf ESC Lorenz. Part solid ABS. Part solid ABS. Okay. So, like a clamp shelf type thing. So, we need a rectangle. Like this kind of. This is gonna be. What's what's 0.3, 1.4 inches to mm? 10. Let's do 0.38. 956. There's 0.38. 9. Okay, 9 times 3. 9 times 3 plus 9 times 3 plus 32 points, so about 33. Let's do 10. Okay, so 10 times 3 plus, how do I change this to scientific? 10 times 3 plus 30, I would say 33 times 2, 96. So this has to be 96. And then this is 96 divided by 2. And then, how big is the clamp gonna be? How big is the clamp gonna be? It's gonna be 72. 72 divided by 2. So something like this. Symmetric. How tall is it? It's gonna be 16 plus 4, which is 20, plus 4, which is 24, plus 16. What's 24 plus 16? I think that's 40. So 40. Okay, save that. And now it's gonna look something like this. How big is the ESC again? 72. Wait. Oh, no, that's the width. Okay, hold on. 33. And then I'm going to center it. Okay. I'm gonna center it. Okay. 33 from here to here is 33 divided by 2. The height of this compartment is gonna be 16. And then from there to there, I think it's gonna be 2. From here to here should be 2. It is. Okay. Yeah. So, and then take this whole thing and mirror it on that, and then mirror those two over that. Okay. And these will kind of be like the clamp shelf situations. What color should I make it? Let's make it white. Okay, so now, actually, we don't need this bottom part because that will be on the ground. Oops. So from here to here, here to here, here to here, and then like this. Why didn't that work? That's weird. I'm just gonna do it a different way. Do this. Do this. Okay, and then extrude. Okay, so now that would kind of be your... This wall probably doesn't have to be that thick. So for this, from here to here, from here to here is how much? 7.5. We need it to be 2. 7.5 minus 2 is 5.5. So from here to here plus 5.5. And then we could take this guy and make it like this too. No, actually, I think 2 should be enough. Okay, and then from here to here, here, pop. Okay. Then create a center line. Mirror this guy over that. And then delete this. Okay, so we just cut down on costs. Let's see if this even fits in there. Let's see if that fits. And then we'll start from there. What did I call it? Clamp shelf ESC. Okay. It might be a little bit tight. Pause. Right here. Get it right, get it tight. Get it right, get it. Okay. Well, that would be your ESC sort of shelf, like clamp situation. The good news is that it does fit. Now I'm gonna need to create like an assembly file for this. Because I'm gonna need to mount this thing onto this thing. So I'm gonna need to create like a little shelf so I can screw into, just like we did here with this thing. We're gonna need to make like a platform for the screws to go into. So let's start there. So this guy could go like that. I'd say about 3.333333333, and then and then we just need it to be big enough. We also need it to fit. So the screw, I'm thinking like 8. Okay, so we're on this side. Okay, so that will fit. Thinking like 8 will fit. And then we're going to need, how many screws? How many screws do we need? Wait, what? Partially placed. You haven't specified enough references? What are you talking about? Can I put, or no? Section is incomplete for reasons listed in message area. What are you talking? This never happened to me before, ever in my life. Maybe I can't sketch on that. Maybe I can only sketch on this part. That's so stupid. Maybe someone has evil eye towards me or something. I don't know. Here's the center line. And then I'm thinking we probably only need 2 screws on each side. You know? So from here to here, I'm just finding the center line, which is this right here. And then it's going to be secured by M2 screws, so 2.2. And then the center line will be, yeah, and then mirror this. Mirror that here. Okay. Okay. Then we could, why can I not sketch on this? You haven't specified enough references to place the section. Sketch anyway. Yes. To select the object, hold down Alt key. Can I sketch on this? Yes or no? I'm so confused. This has to be like 5 or so. Oh, I can sketch on it. Okay. That was weird. I've never had that happen before. Remove a little bit of material. Mirror this, extrude over this. Get it right, get it right. You guys ever see that video? It's funny. You should watch it. Mirror this entire thing over here. Let's see if that fits. I'm getting so lucky with these dimensions, bro, because I already did the cabin, which I just realized needs a window. Actually, does it need a window? This one doesn't have a window. Yeah, I guess it looks fine how it is. But it should have a window, bro. I feel like it should have a window. Hold on. I'm getting off on a tangent, but this needs a window. Let's get some dimensions going here. Oh, nice. Okay. Oh, wait. Spline. Okay. Get it right. Get it right. Something like that. That's a pretty good window. Pretty good window, right, guys? And then just remove material. Wait, what? 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 Why is it creating like a wall? What are you guys doing to my application with your evil eye, bro? You know what it is? I think it's because this guy... Oh, I know what it is. I think... Let's do symmetry, remove material. Huh, that didn't work. I wonder why it's doing that. That's strange. Is it because this is not a flat surface? Let's take this guy. Oh wait, no. Take this, copy. Let's put it on the center. And now we should be able to extrude the material. Why is it doing that, bro? I'm gonna try one more thing. If this doesn't work, I don't know what will. Let's do 0.8 or no, 0.9. Paste, sketch, remove. There we go. There we go. Windows. Oh, no, not gray. White. I'm making it white because that's the printer filament I have. So now it has windows. Okay. Okay, so now back to the clamping situation. The clamping situation. Let's see. Okay, that fits. And then so this piece right here will clamp the bottom two. And then this top piece right here is going to need to clamp down onto something as well. So this part down here is going to need to be rigid. Same idea as here. So they're going to be, I don't know if that's a good design though, because it's kind of holding itself against. I'm thinking we could probably get it right, get it tight, you know what I mean? Let's do that. Let's create a, I think this might be the, okay, that's the top. That's the bottom, and then this is the center line. So we can create like a platform for the clamp to clamp down onto. It's kind of sketchy. I have no other ideas. Oh, I know what I could do. Okay, I know what I could do. I'm gonna create like a little platform right here, like a little thing, so it's holding up, so it has a little bit of structural support when it's clamping down. So this was 8, and then I'm gonna need to create like a little structural support here. It just needs to be like 10. Actually, no, probably 20. Okay. So see there, it will be like a little. This is probably way too thick though, because that's gonna take forever to print. 8 inches in thick. You know, you could probably do 8 inches and then create like a cutout. Like that. About 2. I would say 2 or 3. Maybe 3 would be a little bit more. And then cut out like that. And we could probably get away with that. Okay. And so this way it's like you're not printing too much, you know? You gotta save some space so you can make holes in certain, like that's not gonna, you know, ruin the design or anything like that. But this should probably be like 1. Okay. And then if we print on top of that, we could find the holes that we already made, which is this one right here. And create the same holes for those. So that would be sort of the platform for this guy. So let's copy all that. Over here. Mirror it. Does that still fit? It should, yeah. Okay. And now we're gonna need to make 2 separate pieces. So this is a clamshell ESC bottom. So let's save as a copy. Clamp shelf ESC top. Open clamp shelf ESC top. And then so we can get rid of all of this. Actually, if I get rid of that, I'm gonna have to redo. Yeah. Gonna have to get rid of all of this. As well as this right here. Keeping this right here, I think. Actually, I think we need to get rid of this, not keep that. Okay. Get rid of that, get rid of that. Delete. Okay, so that'll be the top, and then we can make an assembly called ESC clamp shelf. And then we're gonna have to model clamp shelf, ESC clamp shelf. This guy. And then these will be two separate pieces. Okay. Clamp shelf, ESC top. So that'll be the top of it. I just need to fix this up real quick. Okay, so we're getting rid of well, this whole top part. This whole top part is getting deleted. Oh wait, top part, not bottom part. So okay. Actually, hold on. We could probably get away with making this thinner. Like that. Okay. So these will hold the bottom two ones. They'll clamp them down. And then this guy will be clamped. So we need to make a like this. Two. And then just like before, why is it doing that, bro? Okay, just like before, we're gonna need to find the center. Which is right here. Make a circle with 2.2 hole. Mirror against that. And then five. and then take that entire thing and mirror it. Okay, color it white. This guy can be white as well. Okay, and now this is the clamp for the ESC. It probably doesn't have to be. This has to be flat for the entire ESC, for the top ESCs. But I think we can get away with making the top one less material to cut down on cost. So because how am I even gonna print this? Oh, I know, I'm gonna print it on the back. But I would say you can probably get rid of like that much. So get rid of this. Mirror that. And then we are literally just removing the material. So that way it still clamps, but we are cutting down on manufacturing costs and material costs. Okay. So this part is right here. Oh no. Oh, I know what I did wrong. Okay. These screws don't align yet, but they will. We just need to measure from here to here. How far are we off? 0.14. How many millimeters is that? 3.6. 3.6. Hold on, that's the wrong one. Plus 3.6. Plus 3.6. Okay, they should align now. Yep. Yep, see, they align. Okay. And now the ESCs can fit snugly into this clamp situation type thing. We could probably get away with more manufacturing cost reductions by creating like holes in the top. I would say maybe like like that big. 9.5. 9.5 times 2. And extrude. I don't like how it's like that, because then I'm gonna have to remove material. So I'm gonna add that back. That centerpiece. Okay. So now it clamps, it's cheaper. This floor is for the top ESCs. And so now we can add ESC clamp shelf assembly. Let me clear my RAM a little bit. ESC clamp shelf assembly. This guy can go away. You know what we could do is we can create a model. ESC assembly. And then, so we don't have to sit there and doing that on the main model. ESC clamp shelf assembly. I think this is that. So I just got to, these are not, oh yeah, they are, they're aligned, okay. 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 And now I can place my ESC team motor 60 amp alphas. This guy. It's gonna be pretty tight because it's a clamp and it needs to hold it in place. So 0.73. And then from here to the top, that's a little too tight for my liking. But at the same time, I think I measured this 16 millimeters. The actual is 15.9. So right here, 16 plus 0.3. I think that might be a little bit too tight. How would we? Okay. I'm just gonna make it a little bit thicker. Maybe like 0.2 thicker. By drawing like a little like that. can make it thicker by like, I don't know, what would you guys say, like 0.2? This is 0.2, right? Yep. So this actually needs to be reconstrained. So now, as you can see, there's a tiny gap. It says plus or minus 0.3 plus 3D printer tolerances, but I don't want it too loose either, you know. I'm gonna test print all of this, make sure that the assembly actually factually works. But okay, I'm just doing like a little bit of maintenance work on this, but yeah, now the gap's gonna be plus or minus 0.3, and then the gap on this side and this side are 0.01 inches and 0.008 inches. So hold on, let me reconstrain this. That gap looks pretty good. I don't want it to like be too tight, you know. Oh yeah, these holes also serve as like breathing, you know, so it's not suffocating. The bottom ones, there's a hole here and a hole here for ventilation. I think the bottom ones may need a little bit more ventilation though. So let's create some ventilation for it. I don't know why I'm doing all that. Let's do that. 16. Extrude this way. Mirror here. So this will cut down on cost a little bit. Kind of. I mean, there's going to need to be support material printed through there and everything like that. So, but support material is less dense than the infill. So overall, it will be a reduction in saving, plus it will be ventilated. So let's go ahead and add our, and I could probably ventilate it here too. I could probably ventilate it here too, like here and here and here. So create like a small opening. Well, actually, I think I should just make like maybe like that. 24, 14. From here to here is 5. From here to here is 5. So like 5.5. And then maybe like 8. Let's try with that. And then mirror these on there. And then mirror these like that. So there's a bit of ventilation there. So the ESCs will kind of sit mainly on here. They'll be floating a little bit there. Actually, but yeah, like that. So it will be pretty much okay. So now that it's ventilated, let us add an ESC. So now I'm just constraining it. And I guess I can put it all the way to the wall. So the ESCs will be clamped down, so they won't be moving around. At least that's what I hope is gonna happen. I might have to put like tape on it if that doesn't work, but when I 3D print all this stuff, I'm gonna test it. And make sure that it functions correctly. But here, constrain that to the wall and constrain that to the front. One more ESC, constrain it to the wall, and then the bottom, and like that. So there you go. There's your full ESC assembly. This guy could probably be constrained to the bottom. Yeah, that's better. I don't know what I was thinking before, but okay. And now we can get rid of these guys. And add, what is that called? ESC assembly. Oh, and I'm gonna need to make holes for that. Hold on, before I place that, I'm gonna need these dimensions. These dimensions right here. This is 8, right? Okay. Copy this. Right, did I copy it? Copy. Control C. Go to this guy. Oh, there's no holes on that side? Why isn't there holes there? What happened to these holes? Well, let's mirror these guys. There you go. Okay. Ratio it to 1. And what would you guys say is a good spot to put it? Like right here? Nah, probably like -124 or so. Let's just test it. Let's test if that's a good placement. So add these holes, add this axis right here. Coincident. No. See, that's hitting the battery. But if we change these holes right here, this guy, $130, probably like $140, or maybe $150. Let's try $150. Reconstrain. It does it automatically, which is pretty cool. Okay. The battery has some breathing room. The cables can safely come out, I believe, but I feel like they need to be a little bit closer to this way. Let's do 155. Okay. So the cables will still be able to come out. The cables on the ESCs, I think that's going to be the motor wires. The motor wires will be, I think the motor wires will come out from the back, and then the power, and then I'm going to need extension cables for the data signal from here to the Pixhawk. but I think that should be, and then the power cables will go here onto the bus bar. I think that's a pretty good design. So let's finish making these holes, which is this guy. Actually, let's do it this way. Mirror him, and then mirror him and him over here. Let's just make sure that it aligns. Does it align? I can't tell. It doesn't look like it. Hold on. Let's see, this guy. Huh, that's not good. I wonder if this guy's centered. Let's center him. Then we'll figure out what the problem is. Let's see, center them on this. Coincident. So the distance from there to there is 0.08. And on this side, it should be the same. 0.08. Which means this guy is wrong. Oh, I see. This should be, from here to here should be 0.08 inches. Which it is, because 2.05 is 0.08. This has to be 0. And then recenter this guy. Hold on, did I save that? I wonder what the issue is. From here to here, what is this? This is 34. Let me see something. This is 34.95, but this is 37. These should be the same. Hold on, let me check what it's supposed to be. From here to here. Or no, from here to here. What is that supposed to be? What is this in millimeters? 35. So this one's right, this one's wrong. I think that should fix it now. Sometimes I get stuck on a problem like this, but it just takes time. What is this? 0.08. And what is that? 0.08. How many millimeters is that? 2. So this is off by 2 millimeters somewhere. What's 34.95 plus 4? 38. I wonder if I just add 2 to this. Okay. That seemed to work. Yeah, I think that seemed to work because now I can see through the hole. Can you guys see that or no? I'm kind of in the way. And then this hole aligns as well. I mean, it's a little bit off. Like a micrometer. But these are not off at all. I wonder why that occurred. Maybe we should try again. Hold on. This guy has the holes. From here to here, how much is that? From here to here. 37. Bro. This is 37. I was so close. Okay. So now it should be aligned. Yep. There you go. Sick. Now let's add the ESC assembly. let's just do it this way. There you go. Perfect. Is this one constrained too? Usually I get like an orientation error or something, but there you go. Nice. Alright, so now the ESCs are in. Let's see. This is what it looks like as like a structural thing. So the batteries, let's move this assembly too. And this guy. So the batteries are in the center. All the wiring and stuff is going to go through on the sides of the batteries. 4 of these ESCs will be connected. No, 2 of these ESCs will be connected to 2 of these poles. And 2 of these ESCs, the top ones. So it's literally this ESC is connected to this motor right here. This motor is connected to this ESC. This motor is connected to this ESC. And this motor is connected to that ESC. I'm sorry. No, that's not right. That's not right. Because if I do that, actually, so that's, I think, like wiring wise, that's what's gonna happen. But then these batteries down, these ESCs down here. No, I can't. I'm confusing myself. Because one battery powers the bottom 4 motors, and the other battery powers the top 4 motors. So it's a redundant system. If one battery shuts down, the drone will still be able to fly. So it's like a safety system. So these top batteries and these top batteries need to be connected to either battery, but we can say, for example, top is front because it's like top and front. Like if you look on the y-axis, top is the positive x-axis, and the front would be, or the y-axis, and then the front would be the positive x-axis would be the positive y-axis would be the top, and the positive x-axis would be the front. So what's the front of the drone? Where's the cabin at? So the front, so the top would be connected to this one. Where's the cabin at? So the top ESCs are going to be wired to these right here, these bus bars. And then the bottom ESCs are going to be wired to these bus bars, connected to that battery. But that would be a little bit confusing. It's just so confusing. Because then how do like, if the Pixhawk, right? The Pixhawk tray assembly. The Pixhawk has slots in it. It has like motor 1, motor 2, motor 3, motor 4, motor 5. So I will need to take motor 1. If you look at a diagram, drone motor assembly M1, M2, M3, M4, M5, M6, M7, M8. Images. Software configuration. This one kind of has it, but I'm looking for the dual axial. Dual axle. This one kind of has it. It demonstrates my point. M1, M2, M3, M4. I don't think that's facts. Hold on. Pixhawk. This one, oh, this one right here. Okay. 1, 2, 3, 4. So the positive X, Y axis is 1. The positive Y axis, negative X axis is 2. The negative X axis, negative Y axis is 3. And the positive X axis and the negative Y axis is 4. So it goes like that. 1, 2, 3, 4. So this top motor, actually the front of the drone is this way. So this top motor needs to be connected to slot 1. This top motor needs to be connected to slot 2. In terms of power, they could be connected however they want to be in terms of power. Like the batteries. Oh, you guys can't see. Hold on. This is what I'm talking about right here. 1, 2, 3, 4. See? How do I make this bigger? Positive X, negative X, negative X, positive X. How I was saying. So this top motor needs to be connected to slot 1 on the Pixhawk. This motor needs to be connected to slot 2. This motor needs to be connected to slot 3. This motor has to be connected to slot 4. And then five, six, seven, 8. So then it goes backwards. So then it goes positive y-axis, negative x-axis is 5, this motor right here. Then it goes positive x, positive y is 6. Then 7 is negative y, positive x, and then 8 is negative x, negative y. So the slots need to be connected. And then I just have to make sure that that's spinning clockwise, counterclockwise, clockwise, counterclockwise, clockwise. And then yeah. That'll be fun to figure out. That's going to be a whole challenge. I'm going to be at, I don't know if I'm going to assemble it here or at the hackerspace that I joined. But yeah, that's kind of the situation that's going on right now. Okay, so we got our ESCs, we got our flight controller, and how long have I been streaming? Almost 3 hours. So I think that's pretty much it. I did the ESC clamps, I did the bus bars, I added the battery today with some space to kill, but the wires will be there. What do I need to do next? I'm gonna add LEDs for the headlights. So I don't know if we want to figure that out right now or if there's anything more important. But the GPS needs to get figured out. Like what it's gonna sit on. Because right now it's just floating in the air. So I need to create some sort of shell or tray for that. We could do that. Let's figure out here for stand this guy. Here stand. So I don't know if this has mounting screws on it. 10% off, that's $2. Alright, so oh yeah, it does have a screw in the back and a screw in the okay. So I need to order this so I can know kind of exactly the dimensions I'm working with, but for now we can create the platform. And this will be kind of the last thing I do for today, but this is an interesting problem. I could probably get away with making a sort of like platform on working off of this, so I don't have to make extra holes into here, into the GPS flight controller tray. And it will be kind of like one assembly. Like I can put the GPS on top of the Pixhawk. This guy, flight controller tray assembly. Can you guys see? Yeah, you guys can see. So I have to be mindful because there's going to be wires sticking out on top of here on the Pixhawk for GPS and here link receiver, so the controller, the radio telemetry and all that needs to be communicated through a here link antenna, which I'm gonna have to mount back here. So I'm glad the ESCs fit on the bottom, because otherwise I would have to somehow use the top and that would be a whole mess. But I need to make, similarly to this clamshell thing, I'm gonna put like screw holes through it, and then kind of it's not gonna clamp the Pixhawk, because the Pixhawk has like, I don't know if you guys can see those holes right there. The Pixhawk mounts to this tray mount, and well, I'm thinking this whole thing's gonna cost like over $1,000, by the way. Probably like 2,000 or 3,000, like around like between 2,000 and 3,000 in like labor and like me doing it, you know, all the engineering hours. The cost is very high, The first one, the initial one, is always expensive. That's why I labeled that one back there for 10K. This one's gonna be even more than that, because it's like the first one. There's only one of them. Supply is very low. Demand might be whatever. But this thing is very expensive to make. I mean, I'm literally doing all the work to make it, but let's take this tray and work on making holes for it. So it will be here. Let's start there. So the distance between here and here is 1.02 and 0.98. So this is 1. And then we can make 2.2 millimeter holes in it. So this is 0.08 inches. Then we can mirror this guy here, and then we can mirror this guy and this guy over this. Symmetric, and remove material. So now I'm going to create sort of a clamp. It's not going to clamp the Pixhawk, but it will kind of rainbow over it. Pause. So we need to create a new part called GPS mount. And part solid ABS. And we need the dimensions of this. So let's say it's gonna be yay wide, and let's say it's like that. I'm just thinking right now, I don't even, I'm like visualizing stuff, so there's no really words to what I'm doing in my head. It's kind of like I'm very a visually thinker. But I want to make sure this is like that. So what I need right now is from here to here. I hate when it does that, bro. Puts the dimension all the way down there. 1.59. From the center to top. But that's in inches, right? .59 is about 3. Convert 1.59 59 inches. Wait. Oh, it's 40. Why did I think it was 3? Oh, because it's millimeters. So this is probably like 20 or 60, 30, and divide by 2. So let's create a, we can close this out to save RAM. But this guy, this flight controller assembly, we can open them and then insert our GPS mount into it. Okay. Let's measure from here to here. It's 3.4 inches. Convert 3.4 inches to millimeters. It's gonna be this. And then it just has to be a little bit bigger than these guys, a little bit longer than these guys. 2 inches. 2.54 times 2 is 50. So let's do 60 long. It is 60 long. Let's do 70. I'm just kind of getting the dimensions right now, and then I'll mold it into shape. But this guy needs to be constrained onto the flight controller. It's gonna be like yay tall. Analysis 0.7. Let's just say 20 more or 18 more. Plus 18. Okay, and okay, and now we can create like a Pixhawk sort of like clamp sort of situation where these guys, this wall thickness is going to be 2 millimeters. Let's just call it 3. 2 might be a little bit thin. You know what? Let's do 4. I'm feeling froggy today. Let's do that. So see, it's gonna sit over the Pixhawk, and then it's gonna be able to clamp the GPS on top of it. But I think I did this a little bit. It was my first try. So let's do like 10 or maybe 12. Let's see how that sits. It could probably be like 16. And then we can literally create like that. Oh wait, no. Other way. You know what? Let's just start a new sketch. And then we're going to get rid of this. Is going to be 4. This wall thickness is going to be 4. This guy that's on the ground where the screws are going to be is also going to be 4. So we can get rid of all this, mirror it over that. Okay, extrude like that. Yes, perfect. Now I'm gonna need holes right here. Analysis, 2 inches, 2 inches, 50.8 millimeters. Right there. 2.2. Extrude. Sorry I'm not talking. This is just I usually do this in silence. So I'm trying to walk you guys through how I do it, but extrude, do that right there. Okay. So now this guy, I'm gonna unconstrain him and then see if these holes align. It's oriented right now. Hold on. Yep. You can see they clearly and precisely align. This guy's off. I wonder why that happened. Well, let's see how off it is from here to here. Measure 0.12. 3.24. Let's unconstrain this. Constrain it onto here. Now what is it? You know, I think I could probably get away with just moving the holes over 0.063 inches. 1.62, this right here. What? Really? Yeah. Alright guys, I gotta end the stream. Thank you so much for coming, but I gotta go. Like and subscribe. I'll continue this tomorrow. Here's sort of where we're at right now with all of this. And yeah, I'll see you guys tomorrow. Or later. I don't know. We'll figure it out. Like and subscribe. Please hit the subscribe button. Please hit the like button. Comment. I'll see you guys later.